Welcome to this explainer. Okay, I want you to imagine for a second if every single emoji you've ever sent wasn't just, a fun little decoration, but a highly functional tool. We all use emojis every single day to add a bit of flavor to our texts, right? A smiley face here, maybe a thumbs up there. But what if we've been looking at these tiny digital icons all wrong? What if, instead of just being cute pictures, they actually represent an entirely new frontier in how humans and artificial intelligence collaborate and think together? What if emojis were actually semantic operators? It's a brilliant question, right? It kicks off our source manifesto, challenging us to see these tiny symbols not as afterthoughts, but as a really powerful way to tightly compress meaning and orchestrate complex AI workflows. Just think about the sheer density of information a single symbol can hold. In math or programming, a single operator can command a massive function. Our sources propose that emojis, when standardized into what they call Emojiglyphics, can function exactly the same way for high-level reasoning and human-machine interaction. Section 1. Beyond the smiley face.
We're stepping totally out of the realm of casual texting here and diving headfirst into the world of symbolic compression. Think about a clunky, wordy workflow description. Instead of writing out, first observe the data, then objectify the elements, establish relationships between them, and abstract a general rule, man, that is a mouthful. It takes time to read and process. But you can instantly shrink that into an elegant, highly compressed string of emojiglyphics: eye, puzzle piece, chain link, brain. It's a completely compressed reasoning loop that anyone can universally recognize.
Section 2. The 7 modalities of Emojiglyphics. So, the source material maps out 7 specific modalities that act as this massive conceptual leap, showing how glyphs can bridge human intuition and cold, hard machine logic. We've got GlyphCode, where emojis become tokens in a symbolic grammar. We have symbolic interfaces, multimodal cognition that bridges text and visuals, and glyph agents. Then there are compression protocols to shrink complex reasoning, representation switching to seamlessly shift between text and glyphs, and collaborative glyph casting, which is essentially like Google Docs but for symbolic thought. Together, they form a complete ecosystem. Now, let's look at glyph agents, AI agents that operate and think in a compressed symbolic layer. The absolutely crucial thing to note here is that tag at the front, design. That is our first epistemic label, and it honestly tells us, hey, this is a proposed concept, not a deployed off-the-shelf system. Glyph agents are imagined as AI models that don't just parse huge blocks of text, but actually operate within this compressed layer. We need labels like this so we know exactly where we are on the innovation roadmap. Next up, symbolic interfaces, replacing text commands by dragging the refresh glyph and the upward chart glyph. Notice the speculation label here. That denotes a hypothesis. It reminds us not to confuse a super exciting future interface with current reality. But just imagine an interface where instead of typing a complex coding command to sort a database, you simply drag a loop glyph next to an increasing chart glyph. It's speculative, for sure, but it highlights how visual interfaces could drastically wipe out the friction between human intent and software execution. Section 3. The hidden semantic risks. Okay, but you might be wondering, wait a minute, aren't emojis totally culturally ambiguous? Doesn't the thinking face emoji mean something completely different depending on where you are or what generation you're in? Well, this risk opportunity matrix tackles that exact critique head on, mapping out the huge hidden blind spots against strategic leverage points. Take semantic universality. The risk is obvious. Cultural variance in emoji meaning. The opportunity to fix it? Creating a standardized glyph ontology. Or what about cognitive accessibility? A dense wall of symbols could totally alienate new users. But if we gamify the onboarding, it suddenly becomes this awesome opportunity for rapid, intuitive learning. Every barrier has an actionable solution. This brings us to a massive cognitive risk. False equivalence. It's the dangerous category error of conflating everyday emoji familiarity with actual symbolic literacy. Just because you can text a smiley face to your mom doesn't mean you're suddenly primed for abstract visual reasoning. It's a subtle but really dangerous assumption. If we just assume people know how to string symbols into logical arguments because they own a smartphone, we're going to build systems that leave users completely in the dust. Real symbolic literacy requires actual scaffolding and training. To stop us from jumping the gun on interpretation, the framework requires a strict representation shift. You have to start with the eye glyph, observe, literally describe what is objectively visible before you can move to the brain glyph to abstract and assign meaning. This is exactly how the system handles ambiguity. If you just jump straight to the brain, people will naturally assign different meanings based on their own biases. But forcing this sequence builds a shared foundation of reality first. Section 4. Maintaining epistemic integrity.
To keep these visual systems from getting dangerously mystical, we need a safe landing built on rigorous guardrails. We call this epistemic integrity, the practice of distinguishing verified truths from metaphors or speculative claims. Because when things look sleek, clean, and highly visual, people naturally assume the system is flawless. Without this integrity, we fall into over-aestheticization, where the art completely overshadows the actual science. A string of symbols might look incredibly convincing even if the underlying logic is completely broken. Epistemic integrity makes sure the symbols remain a functional interface, not just decorative art.
That's exactly why we embed specific transparency markers directly into the workflow. Fact for verified truths, design for proposed concepts, and speculation for untested assumptions. When you see a glyph block tagged with fact, you know it's solid. Design, you know it's a conceptual blueprint. Speculation, you know it's an untested assumption, like guessing that visual compression universally improves understanding. It literally forces intellectual honesty across the board. Section 5. Building a universal ontology. So how do we guarantee that an AI in Tokyo and a designer in New York read the exact same glyph block the exact same way? This is the ultimate hurdle. If this is going to work globally, it cannot rely on local slang. To move Emojiglyphics from conceptual art to a universal standard, we have a 4-step repair plan. Step 1. Establish shared semantics, a standardized dictionary. Step 2. Create cross-platform translation layers so it works everywhere. Step 3. Implement a versioned glyph registry. And Step 4. Launch an open glyph consortium to collaboratively govern the whole thing.
And here is a hard truth tagged with our fact label. Without a shared ontology, emoji interpretation varies dramatically, and collaboration will fracture. Imagine opening a crucial workflow document from 3 years ago, but the cultural meaning of the key symbols has completely drifted. The entire document would be unreadable gibberish. A shared ontology and version control aren't just nice-to-haves. They are the absolute fundamental requirements for this to survive as a professional tool.
Section 6. The Transfer Challenge.
Let's pull all of this together with a gamification challenge straight from the sources. The absolute best way to grasp symbolic compression is to try building it yourself. Let's look at a basic task. Organize your desk. The sequence is eye, puzzle piece, chain link, lightning bolt, checkmark. You observe the mess. You objectify the elements. Identify the pens and papers. You establish relationships by grouping them. You execute the physical action of putting them away. And finally, you verify the desk is clean. Boom. You've literally just compressed a multi-step physical chore into 5 universal symbols.
As we wrap up this explainer, I've got a transfer challenge to leave you with. Can you design your own glyph block? Try gamifying your own routine tasks to see how far we can push human-AI collaboration. Think about a complex idea you're trying to explain at work. How would you compress it into a sequence of just 5 to 10 glyphs? Could someone else read it? Could an AI execute it? The language of tomorrow might just be hiding in the keyboard you use every single day. So what are you going to encode first? Keep experimenting, and we'll see you next time.